Hi, today this video will go over how to do part of this assignment, April 16th. We might do it over 2 days, but anyway, the first day today, um, the assignment will start with a short, you can read through this for the directions, but basically you're going to read a short essay, see real short, and then answer 5 questions about it. The first one talks about inflation, what it is and why it's important and why you should understand it. The second one is about investing in the stock market and why that's important, followed by 5 questions. All right, so the next part is we're going to do what we've kind of been doing several days already, getting data and using Desmos to evaluate the data. So that's what this video is about here, about getting data first, actual data, real data, and number two, evaluating it using Desmos, and then answering questions like this. I haven't put multiple choices yet. I'm going to go ahead and do that by the time you actually see this assignment. So right now you just see the following questions. So one question is, if we're getting data, excuse me, the first question set is going to be about getting inflation data in the Seattle area specifically over certain periods, and then modeling that data to figure out following things. So, for example, once you get the data, you're going to come up with a function that models the inflation rate. The second thing is, based upon your model, what is the annual inflation rate? Year by year over that period. And also, how could we use that to model or predict future prices in the future? And getting an understanding of how it affects us. If somebody needed $2,000 back in 2010, or even now, or whatever, how much are they going to need in the future to cover the same bills, right? Like if right now a car costs $20,000, in 20 years, in general, prices go up. It might cost 30 or 40,000, right? Even though it's the exact same car and model, for example, assuming it was, what would it cost in future dollars to get that? So that's what inflation does. It raises the prices in general, and so you need to figure out how much more money you're going to need. Okay, so the first thing is how do we answer question number one? How do we get the data? Okay, so that's the first thing. Well, as you can see, I just put the data link right there. And so what you do is you'll click on that. I got to do control click. So you click on that, and then you're going to get the following table that shows up. Okay. Now you can see the various links where you get it from, and you click on that to get the first part. But I'm going to take you straight to it. And more importantly, what it includes is what I've done is I've found data information that is called the Consumer Price Index. That means that's what does it cost for a bag of goods in general that people would have to pay for, etc. So it just kind of measures an index of goods. And it's specifically for the Seattle, Bellevue, Tacoma area, in this area, right? Because different cities can have different inflation rates and different costs. So what it does is it starts off back in the early 1980s at 100. It just arbitrarily makes up a number. It's saying, okay, so if these specific goods like eggs, gas in your car, part of your rent. Obviously, rent's not going to be $100, but it takes a group of goods that most people pay for, and it comes up with a number that represents kind of overall an average of them. So if that's 100%, in 1980s, and then as you can see from this graph, this graph only shows 2015 to 2025. So if you look at it, by 2015, which is way past 1982, it's already at 2015. It's already at 250, which means that whatever you could buy for $100, for example, in the 80s, you could buy the exact same thing, whatever that is, for now it's $250. Maybe that's the way to think about it. And over the years, you can see it gets bigger and bigger. So by 2021, you're looking at about $300. And by 2024, it's about $350. So even though you're getting the exact same thing that you would have paid $100 for back in 1982, you now have to pay $350 for it. And if you wanted to think about, well, hey, what about rent? Well, rent would never probably be like today, would not be $350. It might be $3,500. Who knows? Maybe you got a really nice place. So an extra, if I multiply that by 10, 350, which means in 1980, if I multiply that by 10, it'd be 1,000. So maybe $1,000 rent in 1982 is the same as a $3,500 rent today. You get the exact same kind of place, but you just have to pay that much more for it. So that's how to interpret what we're really getting is a consumer price index. Like I say, it started in 1982 and 100 represented what it was. Okay, so that's some background on what we're going to use as a basis of what something costs at a different period in time. And then over the different years, that exact same thing, whatever it is going to go up by inflation. Okay, and even though it's the exact same thing. So let's go back to our question set, and then I'm going to go ahead and use this site to go ahead and start answering the questions. So our first question was, which of the following models the inflation rate from 2010 until 2025? Okay, so, and now, important, I want you to make sure you understand this. Make your independent variable the years since 2000. So, for example, 2010 for your independent variable would be 10, not 2010. In other words, you would take the year that you're looking at and subtract 2000 from it. Okay, it makes the model easier. So let's go ahead and go back to that data. Again, remember, 2010 until 2025. That's what we want to look at. So I'm going to go back to that. Where'd it go? There we go. Okay. So I don't want to. So if you go to the very top, it's got 2015. So I'm going to turn that to 2010. Okay. So go ahead and do that so you can go through this whole thing with me and then hit go. Okay. So now as you can see, it's now 2010, not 2015, all the way up to 2024. What we want is we want the individual annual data. So as you can see here in 2010, the beginning index was 2026. Okay, so what I want you guys to do so you can copy and paste this easier, because if I try to do it there, it grabs all that stuff. I don't want every month. I just want some beginning value at the beginning of the year. So I click this right here, XLSX. It opens up a new one. Okay, and then you get it over here. So 2010. So let's use a first month. In this case, the index that they've measured was February. So let's just beginning of 2010. Let's use these numbers here. February 2026. Now the issue is what I want. That's the index, right? That's how much something costs. And I got to hit enable adding to be able to do something. Okay. So what I want to do is I want to turn this first year 2010 into just 10 years after. So I'm going to go like this. I'm going to go this number here. So I'm going to go equals this number minus 2000 equals 10, or 10 years after. 2010 is 10. Or I can just type in the values. And then I'm going to copy that cell and I'm going to paste it all the way down. If you know how to do that, it's a shortcut so you don't have to sit and type in 10, 11, 12. But anyway, you should have two columns, one like this, 10 all the way down to 25, and then these are the indexes. So again, remember, what do the indexes mean? It's how much something costs in relation to how much that same thing costed back in 1982, which was 100. So that means in February of 2010, things are more than twice as much as they were back in 82 for the exact same thing, whatever that is. Okay. Okay, so I'm going to copy these. You guys know how to do that, right? You hold down the shift key and your arrow key over, and then you hold on your arrow down, and then you can do control copy. Okay, so the next thing is, and we've done this, but I'm going to do it from scratch. I'm going to go to Desmos so I can paste in the data. So please follow carefully and do this as I'm doing it so you can see it. Okay, so I'm going to open up a new browser. Okay, I'm going to click desmos.com. Okay, hit open graphing calculator. Okay, now I've got a blank screen. You guys might have saved it before, but let's just go ahead and then Control V, paste the data into a cell there, and boom, you see the data. Okay, good. Now, right now it's X1 and Y1. I'm going to leave it that way so I can make my regression model that way. Okay, so the next thing is I'm going to put in my regression equation for an exponential function. So that would be y, I got to make it 1 to match the table. And the squiggly line, which is shift, and then the key next to the 1 is that one right there. Okay, so it's the key right next to the 1. Oops, I don't want that. And then a, which is the beginning value, times b to the power, which is shift 6, to the power of x1. Okay, and you guys have seen this before, so it shouldn't be new, but it basically gives me the parameters of the model. So what does it mean? It means the actual model. Okay, so what does it mean? It means the actual model. I copied and pasted it so I can go ahead and make some. Okay, so the actual model is going to be, remember, the A is from here. So I'm going to put y equals 154, and that's a big enough number that I can just round to 154, times, and this number right here, and I'm going to round that to 1.033. You can round it to 3 decimal places afterwards, okay? And, well, you know what? Hold on. And then, of course, X would be the years since 2000. So that's our model that we're going to get, okay? So now we can answer question number, where'd it go? Sorry. Now we can answer this question here. Which of the following functions models the inflation rate in Seattle from there until there? So again, it would be right there, okay? Okay, so the next question is, what is the annual inflation rate over this period? Well, the model tells you what it is, but what we have to do is we have to turn that into a percent. So what we do, if you remember, we take the B, it's B minus 1 times 100, right? So we have to basically take that 1.033 minus 1, so it would be 0.03. I know you can do it on your calculator, but if you do, you should get 3.3%, okay? So that means every year, on average, the prices go up by 3.3%. Okay, the next thing is, according to the model, what would be the predicted index price in 2030? Remember, this is years since 2000, right? So remember that. So we have to take that 2030 and subtract the 2000 minus 2000. So that would be 30 years since. So that's what I need to put in to my X right there. So remember, so we're going to use our calculator. So I'm going to use my calculator and I'm going to go 150, oops, clear that. 154, because I'm using this function here, parenthesis 1.033, parenthesis to the power of 30, enter. And according to that, the predicted index would be 407.8, okay? So 13 would be 407.8. Now, okay, so the last part is number 14. If someone needed $2,000 a month to cover the bills in 2010, so I circle that, how much money would they need in 2030 to cover the same bills? The key is to know this. You're starting at 2,000. So I kind of wrote it down over here. So basically, what I have to figure out the index in 2010, what it costs for the particular bag of goods for and I need to make that the beginning, because remember, 154 would be since at 2000. So I need to figure out what it is at 2010 for my beginning value. So I'm going to go over to 2010. In this case, it's right there, and it says it's 226. So that's why I ended up getting. Okay, so that's why I ended up getting 226 as my beginning value here. 1.033 there, that's the growth factor. I'm using what we had in the model. And finally, to the power of 20. Why? Because 2030 is 20 years after 2010. And when I put it in my calculator, I get $432.62. Okay, so that's how these problems work.